All right, this is section 3.3. We're going to be talking about graphing quadratic functions. In the previous section, we talked about solving quadratic equations. It's useful to know how to solve quadratic equations so that we can find the x-intercepts of the graphs of quadratic functions. Okay, so usually you will find a quadratic function in the form ax squared plus bx plus c. So you'll have a function f of x equals ax squared plus bx plus c. This is called standard form. And if you're interested in the graph of the quadratic function, standard form is not very user-friendly. Standard form doesn't give you any information about the graph. Well, it gives you a little bit of information, but not enough. And so then there is another form for a quadratic function. It's called the vertex form. The vertex form goes something like this: a times x minus h squared plus k. And turns out that the point h comma k is the vertex of your parabola. So the vertex of a parabola, first of all, the graphs of quadratics are called parabolas, which are these little U-shaped curves. Either the smallest point, the relative minimum, or the relative maximum, that's what we are referring to as a vertex. And so so we have two forms for a quadratic equation. The standard form does not give us enough graphical information. But there's a way to change from standard form to vertex form. Once you have your quadratic in vertex form, then it's easy to know where the vertex is. And also you get information about what's called the axis of symmetry. So the axis of symmetry is just a vertical line that splits your parabola right in half. So here the axis of symmetry, if your parabola opens upward, in this particular case here on the left, my axis of symmetry is the line x equals h. Why? Because it goes, it's the x coordinate of my vertex. Same thing over here, x equals h is the x coordinate of my vertex. Okay, so the graph of if you're given the vertex form, so if this number in front of the parentheses x plus h, if that value happens to be positive, the parabola opens upward. So if a is positive, it opens upward. If a happens to be negative, our parabola opens downward. If your parabola opens upward, then the vertex is a minimum. If the parabola opens downward, then the vertex is a maximum. Okay. Now, there is a little shortcut that we can do here. And this is kind of a nice little shortcut. So if you are given the quadratic, if you're given the quadratic in standard form, if you're given the quadratic in the form ax squared plus bx plus c, then you can still find the x coordinate of the vertex. Because remember, the vertex is a point. The vertex has coordinates h comma k. If you're given the quadratic in standard form, what you can do is you can compute the x coordinate. Let's just call it the x, not x value. Let's say coordinate, because that's what it is. So we can find the x coordinate of the vertex by using the coefficients, the numbers of my standard quadratic. So it turns out that the x coordinate is negative b divided by 2a. Yeah, and to find the y coordinate, so to find the y coordinate, you plug in negative b over 2a into the quadratic, into the original quadratic. Okay, so let's see. Let's get into some exercises here. So you were given a function. You were given a quadratic function. This one is already in vertex form, and you're going to have to do a few things. You're going to have to figure out what is the vertex, what is the axis of symmetry, determine if the vertex is a minimum or you're going to have to determine the minimum or maximum value. the intervals where my function is increasing, decreasing, and what's the range of my function, and sketch the little graph of it. So pause the video, take a few minutes, see if you can take care of all of this little questions. Okay, so hopefully you have answers, and let's just compare our answers. So let's see. I'm gonna look, so they told me that it's x minus h plus k. So and h comma k is the vertex. So h is the x coordinate, k is the y coordinate. The thing is that the x coordinate sign is going to change. So if this guy is plus, that means that my vertex is going to be negative. If it's minus, then it's positive. So right now my vertex should be the point negative 3, negative 6. It's only the x coordinate that changes. The y coordinates, it remains the same. So right now my vertex is negative 3, negative 6. I can see that from this positive 3 right here and this negative 6 right here. The x coordinate always changes, the sign. What's the axis of symmetry? Well, the axis of symmetry, it's kind of easy to find. Once you know the vertex, you just think about the x coordinate. And so then the axis of symmetry in this case is going to be x equals negative 3. And now I need to determine the minimum value or the maximum value. Well, first of all, am I going to have a minimum value or a maximum value? I'm looking at this 2 right here in front of my x plus 3 squared part, and that 2 is positive. That means that my parabola opens upward, and so therefore my vertex is going to be a minimum. So I'm going to have a minimum value, and let's see if we can maybe get a little sketch here. So let's see, the vertex is negative 3, 6. Sorry, negative 3, negative 6. So negative 3 and then negative 6. So down here, that's my vertex, because that's negative 3 right there, and this is negative 6. Good. Now if I wanted to be even more careful here, if I wanted to be even more careful in my sketching of my graph, what I would do is this, and I am going to do it. I'm going to find the x-intercepts. This is what you did in the previous section. So then I'm going to set my y equal to 0. So it's going to look like this, 2 times x plus 3 squared minus 6 equals 0. And now I'm going to solve this. I'm going to solve for x. Okay. So then I'm going to say 2 x plus 3 squared equals 6. Divide everything by 2. So then that should say x plus 3 squared equals 3. Then I'm going to take a square root. So x plus 3 is equal to plus or minus square root of 3. And so then we have two x-intercepts. Well, I'm going to subtract the 3, so negative 3 minus square root of 3 and negative 3 plus square root of 3. And so then I don't know where those values are at. Let's see, let me try to approximate one here. Let me grab a calculator. Do I have one available? I do. So we're going to say what is negative 3 minus square root of 3? This is about negative 4.73. And this guy is going to be what? So it's negative 3 plus the square root of 3. Right now I'm using my calculator over here. This guy is about negative 1.26. 1.27, we'll say. 1.27. Okay, so those are my x-intercepts. Around there are my x-intercepts. So negative 4.73, I don't know, somewhere around there, a little bit before 5. negative 1.27. That's somewhere around there. And that's the best I can do given my stylus. And so my parabola kind of does this. Yeah. So right now my vertex, the point negative 3, negative 6 is a minimum. And I guess you would say well, it's a minimum value. Interval where my graph is increasing or decreasing. Well, my graph is increasing from negative infinity. Sorry, my graph is increasing from negative 3 to positive infinity. That's where my graph is going upwards. So it's increasing from negative 3 to positive infinity, and my graph is decreasing from negative infinity all the way to negative 3. Negative infinity to negative 3. What's the range of my graph? How far down does my graph go? How far up does my graph go? And now you're thinking on the y-axis. So my graph goes as far down as negative 6, and it goes up to positive infinity. So I'm going to say here that we're going to have negative 6 to positive infinity. And why am I using a bracket? Well, because the point, the y value negative 6 is a y coordinate on my graph. Okay, so that is it for this particular example. Let's move on to the next one. Okay, so similar thing. You are given a quadratic function, but this time the quadratic function is in standard form. So it's in standard form, and you're going to have to do the same thing as in the previous one. You're going to have to tell me what is the... Actually, no, you're not. This is two different examples, sorry. So in this particular case, you're just wanting to find the vertex. And I'm going to show you two ways of finding the vertex here. Okay, so let's see. Hopefully you pause the video and try to find the vertex on your own. The first way of finding the vertex, so I'm going to say method 1, is just what they told us earlier. We have a little formula for the x-coordinate of the vertex. And it goes like this, negative b over 2a. Okay. So right now, in my particular case, that's going to say negative 6 divided by 2 times negative 3. So that my b is 6, my a is negative 3. So negative 6 divided by 2 times negative 3, that's negative 6 divided by negative 6. So that becomes 1. And by the way, right now what I'm doing is finding the x-coordinate. So I found the x-coordinate. Now I want to find the y-coordinate. Okay, so how do I find the y-coordinate? Well, once I have the x-coordinate, all I have to do is plug it back into the original quadratic function. So f of 1. Okay, so f of 1 is going to be negative 3 plus 6 plus 1. Okay, so that becomes 3 plus 1, so that's 4. So then it turns out that my vertex is the point 1, 4. Yeah. So that's one method of finding the vertex, is to just use our little formula to find the x-coordinate. Once you find the x-coordinate of the vertex, just plug it back into the original quadratic function to find the y-coordinate, and then you have your point. This is my vertex right here. This is the vertex. Let me show you method 2. You're not gonna like method 2. Method 2 is a little bit more cumbersome. Method 2 relies on completing the square. And well, if you did not like completing the square in the previous section when you were solving quadratic equations, you're not gonna like it now. But I'm gonna show you this method 2 nonetheless. I'm just gonna give you options. It's good to have options. So let's see. So this is method 1. This is completing the square. Okay, so I'm going to do the following. So I'm going to start with my original function, quadratic function. Okay, and I'm going to manipulate it. I'm going to try to make it look like vertex form. So the first thing I'm going to do is I'm going to factor out a negative 3 from the first two terms. So that becomes x squared, and then minus 2x, and then I'm going to give myself a little room here, and then I'm going to have plus 1. So now I got to complete the square. So I'm kind of factored by grouping here in a sense. I just looked at the first two terms. I factored out the coefficient of the quadratic term. From the first two terms. And then I gave myself a little bit of room. And now I'm looking inside this parentheses right here. And I want to complete the square. So to complete the square, what we said is we looked at the coefficient, at the number in front of x. We divided by 2. So negative 2 divided by 2. That would be negative 1. And then negative 1 squared is 1. So I'm going to add a 1 here. Yeah, but be careful. So in order to I cannot just add a value and my function would change. So then think about actually what I did here. Really what I did is negative 3 times 1. So if I actually multiply this negative 3 times 1, what I've done to the original function then is I've added a negative 3. So it's like as if in the first step up here, in the first line in the original, I just subtracted 3. Well, then that means that I have to also add 3 over here. I hope that makes sense. That is kind of confusing, that little step right there, look. And also I should give myself more room here. Let's see. Let me kind of begin this little step here again. So let's see. Let me show you with more detail what's going on here. Okay, so we said, okay, fine. We are going to factor out a negative 3 from the first two terms. So negative 3, and so then we have x squared minus 2x, and then we said that we were going to give ourselves a little bit of room here because we're going to complete the square, and then plus 1, and then we said, okay, well, what goes here? And whatever I add here, I have to do the opposite over here so that it cancels out. In a sense, I'm just adding 0 to the original function. And so then we completed the square. So we looked at inside the parentheses, and we said, okay, what's half? We grabbed this value, negative 2, divided it by 2. So negative 2 divided by 2, that's negative 1. Then we square that, and that becomes just positive 1. So then I'm going to add a 1 inside this parentheses. But adding a 1 in this parentheses is the same thing as actually subtracting 3 from the original one. Why? Because I have to, you cannot forget that you actually have negative 3 times 1. And that would be negative 3. So it's like if I did negative 3. And so if I do negative 3, I should also add plus 3. So that negative 3 plus 3 just becomes 0. So that's why I have to do plus 3 right here. Yeah? So think about that for a second. And so then now what I have is the following. Negative 3. And then turns out that this thing in parentheses, x squared minus 2x plus 1, is just a perfect square. It's just x minus 1 squared. And then, well, 1 plus 3, I guess it's 4. And then I have my vertex. My vertex is going to be the point 1, 4. That's another way to do this. It requires you that you're comfortable with completing this square. It's up to you which one you use. I just wanted to share that with you. Okay, let's see. Let's get into the next exercise here. And you can do it whichever way you want. So you were given a quadratic function in standard form, and you're going to have to find the vertex, axis of symmetry. determine whether the vertex is a minimum or a maximum, and find the intervals where the quadratic is increasing, decreasing, tell me the range, and give me a little sketch of the graph. So pause the video, take a few minutes, see if you can come up with the graph and all of this information on your own. Okay, so hopefully you've attempted this and you have some results. So let's see. Let's first work on the vertex. Again, you could have found the vertex in whichever method you want. I'm gonna find first the x-coordinate. Okay, so the x-coordinate is going to be, we said, negative b over 2a. So in our case, that's going to be negative 2, be careful with your signs, over 2 times negative 1. Yeah, because my b is negative 2 and my a is negative 1. And so now I gotta kind of be careful with my signs. So look, in this numerator, I'm gonna have negative, negative, so that's gonna be positive 2 in the numerator. And in the denominator, I'm gonna have negative 2. So positive 2 over negative 2. So positive 2 over negative 2. So my x-coordinate is negative 1. So I have found the x-coordinate. Let me find the y-coordinate. So to find the y-coordinate, all I have to do is plug in the x-coordinate into the original. So that's going to become negative 1. Be careful with signs and also order of operations. I have to square negative 1 first. So negative 1 times negative 1 becomes positive, but then there's this third negative over here. So negative 1 plus 2 plus 2 plus 4. So that's 6 minus 1, so that's 5. All right, so then I think my vertex is negative 1 comma 5. What's the axis of symmetry? Once you have the vertex, the axis of symmetry is easy. The axis of symmetry is just going to be x equals negative 1. It's just x equals the x-coordinate of the vertex. Am I dealing with a minimum value or a maximum value right now? Well, how do I know that? How do I determine that? I look at whatever number is in front of the x squared part. In this case, the number is negative 1. Since it's negative, that means that my parabola opens downward. So the vertex is going to be a maximum value. Okay, let's see if we can maybe start sketching this graph. So negative 1 comma 5. So negative 1, that's right there. 5 is over here, so that's my point right there. Okay. Okay, good. Let's see. Where does this have? I don't know. I'm not too concerned about the x-intercepts. I'm just going to sort of. This is sort of the behavior that my graph should exhibit. I'm being a little bit careless here because if I wanted to be a little bit more precise, I would definitely try to find the x-intercepts just so that my graph is a little bit more precise, I guess. But I don't care about that right now. I don't need to know that information. Right now, what I do need to know is what is the interval in which my graph is increasing. So from bottom left to upper right, I would say that that is from negative infinity all the way to negative 1. On this x interval, my graph is increasing. So increasing on negative infinity to negative 1. Where is my graph decreasing? Well, I would say that from negative 1 to positive infinity. What's the range of my graph? And now we're thinking in the y values. How far down does my graph go? How far up does my graph go in terms of y? Well, let's say that it goes down all the way to negative infinity and it goes up as high as the y value 5. So I'm going to say that my range is from negative infinity to 5 with a bracket. Bracket y because the y coordinate 5 is included in my graph. Okay, so hopefully we agree on these answers and you were able to find the vertex either by completing the square or by using this little formula negative b over 2a to find the x-coordinate. Last exercise in this section. It's a little application. So let's see, let's read this and then definitely pause the video and try to do it on your own. So we have some little model rocket. It's launched with an initial velocity of 100 feet per second from the top of a hill that's 20 feet high. Its height in feet t seconds after it has been launched is given by this little function, negative 16t squared plus 100t plus 20. We want to determine the time at which the rocket reaches its maximum height and then also find the maximum height. Okay, so pause the video, see if you can figure out the time at which this rocket reached its maximum height and also determine the height at that point. Okay, so hopefully you have some answers. Literally what's being asked of us right now is, well, in our particular application, what's happening is you have what's called the t-axis. This represents time. Over here I have s of t, which is height in feet. And this is time in seconds. So this is time in seconds. And so right now, kind of what we have, the situation that we have is our rocket was launched at 20 feet. It went up and then it hit the ground. And right now, kind of what we're trying to find is at what time did it reach the maximum height. And we're also trying to find the maximum height. So literally what's being asked of you right now is to find the vertex. Find the vertex. Okay, so let's find the t-coordinate, the time of the vertex. So it's going to be, I guess in this case, negative b over 2a, which in our case I guess is going to become negative 100 over 2 times negative 16. Okay, so that's going to become 100 over 32. It's going to be positive 100 over 32, which I guess reduces to 25 over 8. Yeah, so 25 over 8, let's see, 100 divided by 32, so 25 over 8. Let's see, let me give you an approximation of that in decimal. So we have 25 divided by 8, that's about 3.125 seconds. 3.125 seconds. So at 3.125 seconds, my rocket reaches its maximum height. Now, I guess in order to find the height, I'm gonna have to plug into my function. So I'm gonna have to do s of 3.125. Okay, so that's going to become negative 16 times 3.125 squared plus 100 times 3.125 plus 20. Let's do some arithmetic here. Okay, so I'm going to do 3.125 squared times 16. So this becomes negative 156.25. And then 100 times 3.125 is, well, it's going to become 312.5 plus 20. Okay, so let's add all of this. So plus 20 minus 156.25, and I end up with 176.25. So it turns out that the vertex, I guess in this case, in this application, would have been 3.125. That corresponds to the time. And the y-coordinate would have been 176.25. That corresponds to the height. Okay, so hopefully we are on the same page and you feel more comfortable graphing quadratic equations by first finding the vertex. Okay, thank you. I'll see you in the next video.